So I think there is no better way to explain how a tool works than using it. So we are here in the spider web here. We can see a world map with satellite images, RGB satellite images. If we zoom in here in the European region, we can see some market areas. Those are the Nexus Lab pilots. You can see some of them. So what we are going to do now is to check the different possibilities this spider web has, starting with the more, let's say, simple ones and finishing with the crop water requirements and soil water balance. So first of all, something that I am interested in is to find the location I want to work in. So we can use this icon. I know that I will work in an area, in a town that is named Tarazona de la Mancha, but if I have the coordinates, I can also go directly to the coordinates. You will see that. So let's go to our pilot in Tarazona de la Mancha in Spain. So you can see here is like when you search in Google Maps. So we go to Tarazona de la Mancha, and now we are here suddenly in Tarazona de la Mancha. I know this place, so I do not need the exactly coordinates. Our plot, experimental plot, is here. This is an almond orchard. Here is a pistachio orchard, and it's surrounded by many different orchards in Albacete. So things that we can do in this spider web is, well, we can see different layers of satellite data. If we click here in the layers, we can see RGB and NDVI maps. For example, this one corresponds to the April 1st. Let's see the NDVI in this case. And if we click here on the calendar, we can see when we have NDVI data. We can see market here, for example, 1st of April was Sentinel-2. We have in March many days. So all those market days are days that we have NDVI data. What more? Well, we can zoom out also and see that this is for the whole region. Let me come back with this to our interested area, is this one. So we have NDVI. We can do like curves of NDVI between some dates, but I'm not going to stop here a lot because I want to show you the crop water requirements tool and the soil water balance. And for that, what I'm going to do is to click here in this plant icon. And then it asks me, what do you want to do? Crop water requirements or soil water balance? Let's start with the crop water requirements. It's a more simple way to calculate the water requirements in a crop. So we click here to edit the parameters. And it asks me for the NDVI layer. In this case, in this user of Spider we have only this NDVI, but there are other kind of users that can choose different NDVI sources. We can also select the observed reference evapotranspiration layer. We have here, since we are working in Spain, we can choose IMED, that is the national meteorological institution, but we can also use global data sets for the rest of the world. I will choose IMED. Also, sorry, we can use the predicted evapotranspiration. I will choose again the IMED, but as I told you, you can choose global data sets. If you have a vectorial layer, you can also upload it. And then you choose the crop. In this case, I know that is almond, but you can see here that you have a lot: olive, I don't know, vineyard. We have many of those. But I know that it's almond. This is the way how it calculates the crop coefficient for almond. Default is this formula, but you can change it if you have done some calculations. You can change it, but but I know that is in this case 1.44 plus multiplied by NDVI minus 0.1. Then the dates that you want these crop water requirements, and then you just click on accept, and here you select. Here you select the here you select a point. If you click here, you're just going to select a point. If you click here, you are going to draw a polygon. If you click here, you are going to select one polygon if you have upload any save file. So I'm going to do it in just in a point here. And again, it's asking me, okay, are you sure it's almond? Are you sure you want to use this formula? Yeah, let's say yes, calculate, and now it's working. Let's wait a bit. Here are the coordinates. It's calculating. It's taking time because we select some different dates. So let's see if it calculates it. Let me stop the video. Okay, here we have the results. Those are the crop water requirements during these dates between 1 of February and November 30. If you want to know, for example, one exactly month, which were the crop water requirements, you can select here, for example, from June to July. And it says, okay, during that month, the crop water requirements were 136 millimeters. If we select, for example, for October to November, it's very low, it's just 38 millimeters. And we can have also this kind of maps where we can see the NDVI data from satellite images, the observed evapotranspiration, the crop coefficient calculated from this formula that relates NDVI with the crop coefficient, and the crop water requirements. This is a tool we have done with already observed data, but we can do also to predict the irrigation needs. But let's move to the I'm going to delete this just to start from the beginning, and let's move to the soil water balance. So we can come here to the soil water balance and edit some more parameters. Again, NDVI layer of origin, the observed reference evapotranspirations predicted, and now it's asking me more things. Which is the precipitation origin layer? Okay, I will tell him that using the IMED, I will tell him to use the predicted from the NOAA. Then precipitation umbral, we give it in 2 millimeters. And also, again, it's asking me the crop. This is important. The maximum root depth. If you know that your maximum root depth is 1 meter, 0.8 meter, whatever you know it is. Let's say it's 1.5 meters in this case. This is the allowable water depletion. In this crop, we know that is around 40%. I'm not going to change many things just to show you the tool. This is the available water in 1 meter depth. For example, 100 millimeters in 1 meter depth. It asks me if I want to calculate the irrigation. Also, the maximum doses of irrigation. This means the irrigation that you can do in one event. For example, here 15 millimeters. If you know that it's 10, whatever. Okay, I will put again the 15 millimeters. This is the fraction of the soil that is wetted when you irrigate. In this case, we put 0.3 because it's drip irrigation, but with surface irrigation, this would be 1 because all the soil is wetted by irrigation. Let's say here 0.3. And then irrigation strategy. You can irrigate to potential, like all the water needs is that the ones that I want to cover, or you can do deficit irrigation constant or personalized deficit irrigation. I would say that we irrigate around 0.6 of the deficit irrigation, and here you can select the dates. Again, I'm going to move to the irrigation season. Let's say somewhere here, and accept. So now I click on calculate, and it's thinking. Just a few seconds, and now here we have some data. We have the NDVI, we have the irrigation, we have the observed precipitation, and here is the irrigation that we have done during this year. And trust me that it's true that we were irrigating around 400 millimeters last year. How it calculates the irrigation? Because we have the reference evapotranspiration, we calculate the potential transpiration and the real transpiration. We know the evaporation because we know the fraction of the soil that is wetted when we irrigate. So with that, we can calculate also percolation with the type of soil that we have. Of course, it's modeled, but trust me that is quite it has a really good precision. And we have now these results that are very interesting. We have been doing this in Spain in our pilot, but as I told you, you can do this in other coordinates. For example, these coordinates are in Tunisia. So as you can see, you can move just with the coordinates wherever you want. So thank you very much. This is the spider web his tool.